Now, chain rule method of differentiation. Now, the chain rule method of differentiation is also known as the function of a function method of differentiation, or you can also call it the composite rule of differentiation. It says that, for instance, you want to attack a particular building, right? Now, the rule says that if you want to attack any building, first you have to attack whoever that is outside the building first. Now, if you are able to clear whoever that is outside the building, then you can have access to whoever that is inside the building. Which means, for instance, we have our f of x equal to a function x raised to the power of n. This function x raised to the power of n is the same thing as saying all x all raised to the power of n. So you can either write it like this or write it like this. Now, whenever the power of a function is greater than 1, the function you have is also known as the chain rule. The method required is also the method called the chain rule. So let's call this the function we have in terms of chain rule. The power here is greater than 1, which is power n. So what the chain rule says is that, for instance, we need our f prime of x. We have to first differentiate all around, which is that we have to attack whoever that is around the building first, which means that we attack this power here first. The power will come down, and then what we have is still left the same. That is, the x here, people inside the building remain the same. Now, this shows that the people outside the building are the one affected now. So what we have here is n times the people that are inside the building are still intact. But here, there is already a reduction of people outside, which means the ones outside has already been affected. Now, we are done affecting those ones outside. We are done killing those ones outside. So the next thing now, we cannot affect whoever that is inside the building. So which shows that the derivative of x here, that is the attack to x, will give us what? 1. Which means the differentiation of x is equal to what? 1. So simply put it in general, that given a function, let's say y is equal to u of x all raised to the power of n. This is the chain rule formula now. And this given y is equal to u of x, that is a function that is inside, right, raised to the power of n. What we have is y is equal to, the derivative of this function is y prime is equal to n, that is the n. Then we have u of x raised to the power of n minus 1 times the derivative of this one inside. You know, this one is the function, right? So whenever we are differentiating a function, we always have the function prime, right? Now we show that the derivative of u of x is equal to u prime of x. And this is the chain rule formula. This is the chain rule formula. Let's take an example. An example says, given y is equal to x plus 1 all squared. X plus 1 all squared. Now, given this particular function, we see that we can name this our equation 1, right? But from equation 1, if we compare it with our equation here, let's call this equation star. If we compare equation 1 and equation star, we see that our u of x is equal to our x plus 1. So this shows that our u of x is equal to x plus 1. But then from our formula, the power n, our n is equal to what? We see that our n here is n, right? But here n is equal to what? 2. So this shows that we said our n is equal to 2. So applying the formula, we see that we need u prime of x, which is this guy here. So which shows that u prime of x is equal to what? What's the derivative of x? 1 plus the derivative of 1 is what? 0. Then we have this as 1. 1 plus 0 is equal to 1. We've already gotten u of x, u prime of x equal to 1 plus 0, which is the same thing as 1. Now this implies that our u prime of x is equal to 1, and then our n is equal to 2, and then what we have again is our u of x. Our u of x is equal to x plus 1. So returning back to our formula, which is that y prime is equal to n, then in bracket u of x raised to the power of n minus 1 times our u prime of x. We can now substitute everything we have, which gives us y prime is equal to n. What is our n? N is 2. Then into, what is our u of x? U of x is x plus 1. Then raised to the power of n is what? 2 minus 1 times, what is our u prime of x? Is 1. So if we simplify the whole thing, what we have is y prime is equal to 2, then in bracket x plus 1, then times, then raised to the power of 2 minus 1 is what? 1. Then times 1. And this gives us 2 into x plus 1. Because anything times 1 is still the same thing, right? And 2 times the whole of this bracket gives us the same. And therefore, this is our differentiation using the chain rule of y equal to x squared plus 1 all squared.